All right, so we're still graphing linear equations, but now it's when they give you it in point-slope form. So let me write a problem just to get us started. So what I'm talking about in point-slope form, if we go with the problem y minus 3 is equal to 2 times, parentheses, x minus 2. Let's go with that, okay? And I know there's some similar numbers there. But, so anyway, so when we're doing this problem, we're graphing it. Now, here's the joy of this problem. Just like before when we had slope-intercept, if you notice, this is happening right here, okay? My m value is right here, and I have an x1 right here. Now, where this trips people up is that minus sign. If the minus sign is there, the x1, y1 that you're going to pull out is positive because you didn't change the sign from the original formula, okay? So in this case, my slope is right here, right? There's where the m was in the original formula. Here is where my slope is. So my slope in this problem is m equals 2, or I like to write it as a fraction and write it as 2 over 1. My x1, y1, see my x1 in there? My x1 is going to be this, of 2. So my x1 is going to be a 2. My y1, right here, is going to be a 3. Now notice it's a positive 2 and a positive 3 because up here I had my m value and then I had my x and my y1. So now to graph this, I'm simply going to plot that point. So I'm going to go to the point 2, 3. 1, 2, 3. Plot a point there. Then I'm going to move the amount of the slope, which in this case means I'm going up 2 to the right 1. And I'd be plotting my point there. All right, this one's a little trickier, so we'll take a little more time with this one, but just giving you a general idea of where this one's coming from. All right, so in this one, I'm gonna write the formula directly underneath this. So the formula is y minus y1 is equal to m times x minus x1. Now, for instance, here, this y value and this x value never changes. It does not ever become anything other than y and x. It's always y and x. So I'm paying attention to what is this y1. I'm paying attention to if it's a minus, then I'm pulling it out exactly. If it's not, I need to do the opposite. I'm paying attention to what's sitting right here in the formula, and I'm paying attention to over here in the x1. So in this problem, I can see there's my m. My m is a negative 4. So I'm going to be able to pull out right away this m equals negative 4. Okay? Just pulled it out from this location. That's all I did. I extracted it. Now, I got to look for my x1, y1. When I do that in this problem, my x1 right here, notice how the minus sign is the same? So my x1 is a positive 2. My y1, okay, do you see how that's a minus? Oh, this is a plus, which means I'm going to have to take the opposite. So my y1 is a negative 2, because I had to take the opposite. So now I'm to the graphing part. Again, I'm going to graph that point first, which is at where x equals 2, y equals negative 2. I'm going to plot a point. And then I'm going to move that slope. Now remember, that negative 4 is also negative 4 over 1, because I need to have the fraction. So that means I've got to go down 4 from that point to the right 1. So I'm moving down 4 to the right 1, and then I connect my dots, and I draw arrows at the end of my line, and I'm done. Again, I know this one's a little bit trickier. There's more to pulling this stuff out correctly.